Now I think it's Victor one SS3. SS3.
Okay.
Stop. Okay, my name is Isabel. My name is Treasure. My name is Robotics and Automation. My name is SSB. My name is
Okay, so we only have one person from the GSS class. Are you present the entire GSS class?
Recovery is one of the most in-demand skills in the world generally. People watch some of these tech documentaries. You see children in China from primary school. Some of them are already building homes. Some of them are building beautiful automated systems, tablets. Here in Africa, in Nigeria, they are still playing in the sand. So it's high time we start changing the narrative. When I was your age, I was in secondary school like this. Many years ago, we didn't have this opportunity. So somebody thought it's important that he passed through this school and he did not get this benefits. Now he has gone out there, he has traveled out of the country, and he has seen that students from primary school are doing wonders. And we, even at the university level, Nigerian students are still struggling to even understand what these things are. So this is a way of him giving back to this school that brought him up and he has decided to organize this. So I'll be trying my best to explain what I can to us. This is our first class, so
This box, you see inside, it's called an Arduino kit. It comprises of components and sensors. We'll be learning about a lot of them. We'll be making use of them to do automation, to automate things. You see what I have here? What does this look like? It looks like that thing we used to put a pigeon. But since pigeon can live inside, it's still a house. Just pigeon house, are we? Okay, but it's a house. Now, we'll start by building things like this and automating them and making them to work without us interacting with them. It is all about building systems that interact to the environment. Now, robotics is part of a branch called artificial intelligence. Artificial intelligence has different branches. Robotics is just one of them. And artificial intelligence is just making inhuman things, inanimate things like this to behave like humans, to learn the way humans learn, to react the way humans react. If something stings on your leg now, you raise your hand to touch it, abi? So we can also create things that also react with hands, that have legs and can move. And we'll be learning how to build those things as we progress. So know that all those fall under a branch of artificial intelligence called robotics. So since today is our first basic programming, now where these three things comes into play is these systems need electricity to move, to function, to work. The mechanical part will be you applying some skills to build things. Then we'll connect them to electricity for them to move and do other things. Then the programming part is the brain behind it. It is writing code. Once you switch on the light bulb, it goes off. No current is passing through it. You know electrons. So it doesn't light up. It's a component that is called a switch. That's what we have on the walls there. It won't work for these ones. Now there are three things we need to know about electricity. We need to know about the voltage. Who knows about voltage? Who knows voltage? We need to know about current and resistance. I like okay. When I'm teacher, I like hearing okay. So whenever it comes, allow it, let it flow. for this thing to light up, something needs to push. So more voltage means more push. Then there is another one called the current. Current is just the amount of electrons that is passing through. Those times that you say, we have low current. I like okay. When I hear okay, I'm happy. That time you never will bring light. When people are happy, you are angry at home because the bulb is just red, looking at you as if you are annoyed. You say it is low current. That is because the quantity of electrons that is flowing through in that your area is very small. So the current becomes low. So it means more current passing through, more electrons passing through will give you more electricity. Then the last one is called resistance. That is, let me put it this way. Resistance is, let me say you are resisting, this you are pushing back. So something that reduces the flow of current, it alters the flow of current. So if your current is too much, have you ever put on your bulb, put on bulb and hear poof? You know what happens? Too much current. Each of this bulb, the fan and all, they have the amount of current that they need to work. So if you supply too little, they don't give you full light. If you supply too much, they blow up. So some of these lights need a certain amount of current, but most times the power source that we have, the battery, the NEPA light, they all come with more power, more electrons than the load or the bulb needs. So what we do is there is a component we add, it is called a resistor. What it does is it reduces the flow. So when, let's say, a current of 1000 is coming and this only needs 900, what the resistor will do is it will stop that current and only allow 900 that this one needs to pass through so that this one will not blow up. So have this concept in your head. Now, still on electricity, we have the DC and the AC. Who has heard of them before? DC is direct current, AC is alternating current. Alternating current means it is not stable, it is flowing like this. This is the type that comes from NEPA lights. DC means it is direct current, it is flowing the same quantity. That is the type that comes from batteries. So whenever you hear, I would have to go too deep. Whenever you hear DC, that is direct current. Or you are alternating current. When you hear direct current, think of battery, any type of battery at all. So this one is a battery. This is another battery. This is another battery. The one you buy in your remote is what? Still battery. So all this is. So whenever you hear, I would have to go too deep. Whenever you hear DC, that is direct current. Or you are alternating current. When you hear direct current, think of battery, any type of battery at all. So this one is a battery. This is another battery. This is another battery. The one you buy in your remote is what? Still battery. So all these things they produce a type of current called direct current. And that is because the amount of electrons that are coming out of this is the same, it doesn't change. If you look at this battery, you see, pass it down. You see something is written there, it says 3.7 volts. That's 3.7 voltage of electricity. That is the force that it has. So it is giving you 3.7 all through. So there are other different types of batteries that we have. But now let me show us some components that we'll be using. The battery is all done, let it come back. Okay, one is back, it's made it back. This is called a battery holder. So because most of the things we'll be doing, we'll be making use of electron I'm talking about because it is much, it comes to you. The same thing is here, but this one is not much. It's not much for our body. So our body can take it. Don't think it's not shocking. It's shocking like this. But it's not much, so you're not feeling it. But when you touch the one that is bigger than you, even if you don't, you start hearing smell will go to it around. So we'll be making use of batteries a lot. We have these jacks called battery holders. We have some you see, these are called LEDs. So what does LED mean? Light emitting diodes. I think I have an electrician here that is using identifying services. Okay, so these are the lights that we'll be using. You see these ones, they don't require too much light. If I try to connect it to this now, you don't hear the sound of it. It will go. Now, so that this light does not become too much and kill this battery, we have these ones called what? Resistors, providing resistance. So if I want to connect electricity that is more than the capacity of this guy, what I'll do is I'll connect this one to it so that it holds it. So in here we have a lot of other sensors. This is a screen, LCD display. This is a key cards. You know that type of you see those type of doors that when you put cards it will open. This is the type of things that are used. So we're using them to build. This is called joystick. Alright, I'll open it. It will work for this thing. I'll make it work. Look at this game. So you can write a game, build a game system. See that car I was controlling that day. You can use this one also to control it after you program it. So we'll make use of all this. This is for display. This is called 7-segment display. Have you seen something like this before?
Yeah.
So we have them in different types here. We have small ones and big ones. So you program all of them. Look at keypad. So you can decide to go to your principal's office, and when you learn this thing very well, you go and code it. Use this one, put key, and remove it and run away. I did see that. So you're not called. This is the main thing. This is a microcontroller. It is called Arduino. It's an Arduino Uno R3 board. You need to write that one down so that's what we'll be using. Arduino Uno R3. That's the microcontroller that we'll be using. This is it here. So this is what we'll be writing these programming codes into to tell every other system that we're doing what we'll be doing, what they should do. Make them smart and automated. This is a relay switch. Now, because the power that will coming out from Arduino will be too small to power this your fan, to power this board, I can use this one to connect. So it means that you can use this thing to make even your house to be automated. But you need a relay because most of your electronics, your TV, does not need battery lights. It needs NEPA lights. So for this battery light to work with them and connect to NEPA light for this, you need something called a relay station. These are all sensors. This is water level sensor. We're building an irrigation system as we go along. You know what irrigation is? So that if you have your farm and you don't need to be going to farm every day to check, rain no fall, the water okay in the soil, you can use it to build a system that checks the soil. If the water becomes low, you can make it to trigger a reservoir. You have a tank or a river and you have a pumping machine there. On its own, it will pump into the soil. When the soil becomes saturated, the machine will stop on its own. We're building a lot of things in this place. This is a motor. You know this one, huh? Yeah. Motor. Motor is a phone. No, this is motor. This is another motor. We have different types of motors. What makes this your fan to turn is one of these. So we'll be using them to do, let me see, if you are serious, we'll build drone, we'll build helicopter, maybe to fly. It depends on how serious you are and how fast you can learn. Now these cables are called jumper cables, jumper wires. That's what we use to do all our connections. This is a variable resistor to control resistance. This is another type of motor. So it's called servo motor. This is what's the name of this one? Ultrasonic sensor. With this one, you can build a system that if somebody comes close to a door, the door will open. The person goes out, the door closes. You can do it in a way that if someone comes close to it, alarm will sound. So you can use it to build a lot of things. They are all called sensors. So these are some of the components that we'll be using to build a lot of things that we'll be building during this training. And mind you, it's going to be hands-on practical. Do you know what this is?
Yes, sir.
What is it? It's a multimeter. It is used to check voltage, current, and resistance. So if you want to know, if you know that this light needs just 4 volts, let's say 3 volts to power on, you can use it to check how many volts this battery is giving out. Check how many volts this battery is giving out so that you will be sure that it is not giving too much electricity to this. Otherwise, this one will go off. So we use this to check this for safety purpose. So when you calibrate it and you check, can you hold it? Can you hold it around? So can you see it from there?
Yes.
What is showing us? That means the power in this thing, the voltage in this thing is what? 6.03 volts. So it means that if you have a component or a sensor that needs less than 6 volts, if you use this battery, this is what we use to do safety. One of the things you should also know that components have what is called polarity. Someone has heard the word before. Polarity. Yes, what does it mean? Okay, but you have heard it before. Okay. Polarity means positive and negative. So batteries must always identify the positive part and the negative part of every light source. If you touch, even in, let me not tell us this one, somebody will use their tongue to test light. So you must always identify the positive and negative side because most of these components also have a positive and negative side. So I will show you us this LED and you see the LED. From this side, what's your love? One is longer than the other. When you see a component having this, where one leg is longer than the other leg, this long one is what? Positive. This one is what? Negative. So if it's not having long and short, then it should be having color codes. Red is what? Black is what? So when I wanted to test this, you see even the multimeter is having how many colors on its codes?
2 colors.
So this one is what? This one is. So if I want to check the voltage of this, I put positive to what? And negative to what? Now, some, when you connect them in the reverse order, you connect positive to negative and negative to positive. Some components will get destroyed. It will burn them. Because remember, I said current moves from positive to negative. Now you are sending the current in the reverse order. So it will destroy it. That is why we need to know about electricity and how it is connected. So in the same way, if you want to connect this, you want to connect this to any type of light source, you must make sure that you connect positive to positive and negative to negative. So if I want to connect this directly to this power source, I must first check this battery. Here is the positive side, here is the negative. It's always written. You can see here, there's a plus here, there's a minus here. Meaning this big side here is negative, this is positive. So if I want to connect this now, I should connect, here's the positive now, positive, negative. And here this is positive, this is negative. So if I connect it this way, this, see this way light. I want to see if the current will become too much. So I think they are okay with each other. If the current is higher, without a resistor, it will burn. This one will blow up. Let me go see the voltage coming out of this. You think because it's small? This one is 6 points. This one is 4 points. That's the question so far. Any question so far? No question. That's a question. All right.
When I want to go back and I put the red wire, like the positive, on the other side, because I don't put it back on the other side.
On the motor. Now, the way this motor works, if it sparks, what sparks? The motor sparks. And it's not supposed to. Now, this motor, it works in two ways. Now, the way this thing works, or in next class I'll show us properly. The way this thing works is, if you connect positive here and negative here, it turns in one way. If you reverse the connection, it turns the other way. I don't know if you understand that. That's how it's supposed to be. If you put negative here and positive here, it will turn like this. If you now put positive here and negative here, it will turn the other way. So you can make a fan to turn this way and this way. This is what is written in sort of this. Okay, so now what we have built here is a simple circuit. What we have built here is a simple circuit. What it contains is what? Our battery. And what other components do we have here? We have the LED. So if I have this my LED like this, my Arduino. So this is what? Positive and this is negative. So this battery now is having the positive terminal and the negative terminal. So if I want to connect, what do? I connect this negative, positive, positive to positive. And if you do this light will come up. But now, because you don't want the situation where the backing power will become too much, remember, if you are using MP3, you don't know the capacity of the battery inside, but you always charge it. When the battery goes low, you charge it. So it is possible that that battery can be fully charged and you continue to charge it. You always do it. You forget it there to charge to fully even cover. On the MP3 become charged. So in situations like that, this thing cannot charge more than itself. But to prevent it from having too much charge and giving too much charge to components, these components that requires something that will step down the current, you can now put what? A resistor here. You can connect a resistor here to this point. Do you know why? Because current will flow from positive to negative. So if this thing needs, let me say, 4 volts, and this battery, like you saw on this one, is having 6 volts. That means 6 volts of 6 voltage is passing through here, but this one needs just 4. If you put this here it will be 6. This one now will reduce the voltage. And what you are having here, depending on the type of resistor you are using, will before, which is enough for this one to survive. Do you understand that? So what we'll be doing now is we'll be building something that looks like this. This more practical together. Huh? I want us to group ourselves into three different groups. I need three groups. Just spread yourselves out. Don't do class theory. Put yourself around the group. Go to your groups. Now, this will take this. You take this now. This is group 2. I want to see your groups together. That is one group. All right. Now, you see this? What do I call this table? Hello. Are we together? These are jumper cables, right? Now this cable has points. You see this one? You have things here. Anyone that is having this, that side is called the male side. On the both side, that is female to female. Those are the types of jumper cables that we have. So now each group is entitled to one LED. Who is leading this group? Good. Group 2. We are doing group 2 this color. And let's have group 3. Here are the group 3 members. Only 3 people, so they are group 3. Why is group 2 not 2 people? I have 2 of you join group 3. Yes, you 2 join group 3. Yes. Okay. We all have LEDs. That is the one in this one. This is called a breadboard. Breadboard. Don't eat it, it's not bread. It's a bread. It is breadboard, it is not bread. Alright, now if you see this thing, it comprises of holes. These are holes that we use to do connections. So now, if you hold it like this, you see this line here. How many lines? How many holes have you seen on each side? 5. This 5. This 1, 2, 3, 4, 5 here. They are connected. Horizontally like this. So, and these ones too, they are connected. But you see these ones here, they are connected vertically. So, anything I put here, and I connect another thing here, they are all connected on the same line. Okay? If I connect something here on this one, and I connect another thing here, they are all connected together. Take note of that. So these ones are connected horizontally, this one and this ones are connected vertically. Okay? Alright. So now, what we want to do is to connect the positive and the negative legs of the what is it called? Of the LED. We want to connect them on different points. Okay? So what I'll do is I'll connect any of the holes. I'll put one here and put the other one in another hole. Okay? Just press them inside. Take note of where you are putting your positive leg. Your positive leg is here. You can try to put your own anywhere. But remember, electricity flows from positive to negative. So we need to know so that when we are connecting our power source, we know that we are connecting positive of power to positive of what? The LED. Alright, so make your connection now. Somebody should leave the door. Please look at what he's doing and make sure he doesn't make any mistake.
No. Yes, sir. This road.
So you don't. Are you sure? Yes. We are doing this. So we have connected the LED and we have connected one leg of the resistor to the LED. So where is the second leg of the resistor going to? From the circuit diagram, where is the second leg going to? To the positive of your battery source. Hello. That's what they are placing that. Is that the basic process? No, they connected. Okay. Are we together? So, additional connection is correct. They are on the same horizontal road, right? Alright. Hello. Are we together? So, see, we have positive of LED to one leg of the resistor. This is the resistor. The second leg of the resistor is to go to the positive of the battery. Now, because I don't want to be carrying my battery everywhere like this, I will now place this one. You see this one I say is connected like this. You see, here is red, here is blue. Red means what? Positive. The blue now is negative. I see there are two lines there. So I'll place this one. This is coming from the positive of the battery of the LED. And it's supposed to go to the positive of the battery. I'll place it inside this red side, any one of these. So connect the other side of the resistor to the red side of this breadboard. Oh, you want to have color? If it's not having color, just know that take one side as negative, the other side as positive on this last edge. So anywhere you connect the second leg of the resistor to, know that that is where the positive of your battery also will connect. You understand that? So now we have this point connected, this point, and this point. Now we have to bring this one to the battery. This is where I'll give you a jumper wire. So we are doing positive, so I'll give all of you a red wire. Pass one to the other. So what I'll do with that wire now is I will connect. Since this one is they are all connected like this. So if I place this on the same vertical angle of like the LED, which they are connected, right? So if I take this now and connect it to my battery, so the positive of my battery, it means I have completed that positive part. That's correct. Is it clear? Alright, do the same thing. But don't connect your battery yet. Just connect the wire. I want our circuit to have positive and negative. So we can now connect the positive of battery and negative of battery. Okay? Alright. So with what we have done now, with that wire in place, we have this. It's just to connect it to our battery. The second leg of your LED is connected directly to the negative of your battery source. So negative is always depicted by what color? Alright, so I'll give all of us a black wire. Next one to them. So what I will do now is, since I have positive, see where the LED, the other one is. Remember, all these things are connected. So I can just connect it on the same, any of them, any of the five. So since, see, this thing, where is negative? This is negative. So if you connect this wire now, any of these lines on the same line, it will be connected to the negative ones. So if you have done this and you have done it correctly, it means we have a full circuit connected. So what you are seeing here is the same thing as this. The only thing we need to do now is to connect positive to positive battery, negative to negative battery, okay? Alright, so let me see if my own will work or it will blow up or it will not work. Positive, negative, and I have electricity. Alright. Oh, somebody has succeeded here. It's like never light, just
Not backlight.
One is not correct.
none is so correct. It's possible that your battery is down. Or maybe that's the color of the light. So try to this battery. That is the one. Not on. Hold on, let's see your connection. Hold on. Where the possibility of your enemy?
Yeah, 4 o'clock on it.
So,